Hello and welcome to a very special session of Digital Futures, where we'll be looking at OpenAI's Sora, the text-to-video platform that has recently been announced in the middle of February and which has taken the world by storm. We've had text-to-video platforms since late 2022, but this one is really a game changer. It is a different order in terms of the quality of the video produced. Today, we have a panel of digital futures experts who are here to discuss this tool. To be clear, none of us have actually used the tool. It's not available yet, not expected to be available until the autumn. But nonetheless, we've assembled here some of our leading members of our team in terms of working on AI. It's a great pleasure to bring everyone together for this session. We have Bolojan here, who is both a key figure within the world of Colombo in developing their deep Vermillion model, and also an assistant professor at Florida Atlantic University in Fort Lauderdale, in Florida. Wanyu, who is the CEO of XCool and prolific all over the world in promoting that platform. Colombo, who is relatively new to Digital Futures, but someone who has been behind the scenes producing some astonishing work in the past year or so, working with Ross Lovegrove, based in Dubai, and someone whose background is not architecture, but someone who is, I think, is set to really have a huge impact on the world of architecture. George Guida from Harvard has been a tutor on several of our sessions. It's great to see George back, as indeed has Daniel Escobar, who's currently based in practice in Lima, Peru. We welcome back Joshua Vermillion, who is a professor at the University of Nevada, Las Vegas, and one of the most prolific, most active members in terms of the world of AI on Instagram and elsewhere. And Angelica, who is not only a member of our team as Digital Futures in charge of the Portuguese language platform, but also as a crucial, also very central in all the debates going on in academia in Brazil, where she is a professor. So we've assembled this team just basically to kind of share some early thoughts about this. But I will start off by showing you a few videos of what is available. Maybe I'll switch off my video so you can see the videos much better. And I think what is very, very clear is that all of a sudden we are in a one second. We are in a completely different domain when it comes to the kind of the quality of the image and so on. What we have seen, so the only people who've had access so far to this have been I think it's called a red team of experts who have been testing this out. And all that literally we have are these videos which have been posted by OpenAI, although they did post a report telling us about how they achieve these techniques. So here we have some galleons in a coffee cup, truly extraordinary in terms of what you can generate. This again is text to video, so it's based simply on a text itself. And there are a bunch of these that have been posted and are increasingly more posted every day that can be found on the OpenAI website that just give you a clue of the range of this thing. I think the important thing to notice is that they're able to these videos can last up for a minute each, and what is remarkable about it is they keep faithful to the original prompt and maintain a high level of visual quality, including extraordinary visual detail, as you see in this close-up of this face. Truly, truly remarkable. In fact, there are even videos going even closer up, and you get this amazing resolution and detail in the video itself, with astonishing reflections in the eye itself, and so on. So it's not been so everybody who's seen this has effectively been shocked by the standard. This is effectively a game changer that we should say in the field of AI itself. That sometimes you can see a few glitches that come out in this particular video. It's interesting as this person moves her what appears to be her arm across, but then you're not sure if it is her arm, and then the cat appears to have three front legs. There are some things that are still to be resolved. As you can see, there's a rather curious extra leg that appears there. But it manages to do most things fairly well. The challenge has always been with text to image generators is the problem of, let's say, having an extra arm or an extra finger or an extra digit, anyway, so to say. And this is not without its faults, but you can see nonetheless there is something astonishing that is coming out of this. An exquisite detail, exquisite detail. The question ultimately is what will the impact be of this new tool on many different industries, including architecture itself. Clearly, we're talking about a game changer. A chameleon, a favorite animal of mine, since I wrote about it in my book Camouflage. I would like to have seen this chameleon changing color. It doesn't change color, but nonetheless, again, some of the detail is absolutely exquisite. Then this maybe is my favorite of all, because not only do we get this astonishing, exquisite detail, but you're able to see how this can handle 3D. As this bird turns around and changes the direction of its neck, you can see all of a sudden how well it can handle the complexity, the three-dimensional complexity of a scene like this. So it's no surprise that people are just shocked by the quality and by the resolution of this thing. So how do they do this? Well, the way that they've done it basically is operating very similarly to the large language models, the GPTs and so on, that are behind ChatGPT, that are behind Midjourney and so on. These models basically have now been adapted in some sense. So the difference, for example, in terms of ChatGPT is that instead of using tokens to represent words, they use what they call patches. Just to quote OpenAI, we take inspiration from large language models, which acquire generalist capabilities by training on internet-scale data. The success of the LLM paradigm is enabled in part by the use of tokens that elegantly unify diverse modalities of text, code, math, and various natural languages. In this work, we consider how generative models of visual data can inherit such benefits. Whereas LLMs have text tokens, Sora has visual patches. Patches have previously been shown to be an effective model, but a effective presentation for models of visual data. We find that patches are a highly scalable and effective representation for training generative models on diverse types of videos and images. Each frame then is broken down into patches in the same way that words are broken down into tokens in training LLMs. And this allows it to have a certain flexibility on a wide range of videos in terms of their resolution, orientation, and aspect ratio. So this is a video of a gold mining town during the gold rush. And understandably, as we'll see in a moment, this has led to certain consternation in certain quarters in Hollywood because you can do these things so remarkably well. Again, a beautiful art, of course, for architecture as well, but not necessarily without its glitches. We see these individuals here coming in here. You notice that they somehow disappear into the balustrade at some point, and they've clearly cherry-picked to some extent these videos and cut them short when they break down. They don't necessarily go on that long. 1 minute, 60 seconds the most, and most of them are much less than that. So, but nonetheless, you can get a glimpse of the potential of this extraordinary new world. What's more, it's able to exhibit what are called emergent capabilities. This is a term that's been used to refer to LLMs as a whole. The way in which they've managed to do things, you can see also here, they stop short of this railing here because you can see it's going to be a problem. So this is Sakura, this is the cherry blossom in the snow. I'm not sure that's the same season necessarily in Japan, but still a remarkable sort of video. So the emergent capabilities are things that appear in these large language models that are not whereby they're capable of doing things such as translating languages, writing code, and so on. And I would claim designing itself, tasks for which they've not been specifically trained, and they're able to do this. Now, one aspect of one of these emerging capabilities here is dealing with what they call occlusion. That refers to when something's in the scene and then disappears, in this case behind a building, as you get this reflection suddenly of this individual on this train in Japan, and where then you can come back to the scene itself. So it's maintaining that is remarkable, and be able to do that is something very special. At the same time, we could probably, if we look closely, if you look very closely at what's happening, you can see that maybe it's not quite the same scene as we see before. So if you just watch right now, right before the scene disappears, and see what you're getting, and then right now, and then look, and there's not quite the same scene as you see coming out the other side, but not that that matters because you're not aware of that. But it's these remarkable things, emerging capabilities, that really make it extraordinary. And the most remarkable of all is the kind of way in which it can handle 3D, or seemingly handle 3D, being able to work so convincingly in this. In this particular video, which is the only one they have that give it 60 seconds long, everybody's walking in the same direction, which is, I'm wondering whether it was capable of handling people walking in the other direction. But the most remarkable thing is you zoom in to see this face in absolute exquisite detail. So you can go from an urban scale right down to extraordinary detail with the reflections in the sunglasses of the scene outside. This is truly, truly remarkable. But more especially, it's remarkable because other people have been experimenting with this and to be able to use this as a 3D rig and then use other icons on top of this. So let me just briefly introduce one of the very early kind of responses for us. As soon as this came out, people were starting to experiment with this and noticing that they could do extraordinary new things. And no doubt there'll be many other things that will appear in the future. So let me just show you one video of what one person has done with this particular tool.
Visual media has just changed forever. This video behind me is fully AI generated using Sora by the company OpenAI. There's not a single live action element in there. That was from a text prompt. I put the prompt in the description. Now, what I just did is I took that video, it's fully AI generated, and I ran it through Wonder Studio. And this is a tool that actually lets you animate full CG characters, replacing them with live action subjects. And so, normally this would be real life footage, but instead it's AI generated video, but yet I'm still getting full on motion capture data, and I'm getting a full 3D rig. Now, Wonder Dynamics lets you bring in your own CG characters. So this could be any model, any subject that has a bone system and a rig, but this has tremendous implications for the media industry. Things will never be the same. So my question to you is, what are your thoughts on this?
Exactly. What are your thoughts on this? It's able to do other things, I should say. It's able to take an image and extend it either forward or backwards. So technically, you could even produce a continuous infinite loop of a kind of video. So this is clearly a game changer. These emerging capabilities, the things that it's not been trained for yet, it's showing itself capable of doing, are to my mind, the most intriguing aspect of these LLMs. It's not based on the code itself. It's based on the amount of data. The more the data, the more these emerging capabilities appear. In fact, the code itself is relatively minimal. Well, not surprisingly, this has shocked many. And Tyler Perry famously abandoned a proposal to build a $800 million studio expansion after seeing some of these videos. And you think back at the the various issues that were going on, the demonstrations that were going in Hollywood about actors trying to preserve their profession in some senses and not having their voices stolen, and not having their image stolen and being used by other people. Well, that seems ancient history now that we have this particular model in operation. And of course, we don't know. OpenAI has not declared where it gets its sources from. So, but it does have implications for the world of architecture, and especially, I would say, for the metaverse. This video, which came out, I think, just yesterday, of an interior, is in many ways extremely shocking because of the quality. We have never seen anything like this in the world of architecture. What are the implications for architecture? Will it be an incredibly useful tool that will help us along the way? But will it threaten to put people out of work? Who knows exactly? But I think the important thing is to be aware of this. So today, then, we're bringing together a whole team of a whole group of our Digital Futures team to discuss this, to speculate about what is going to be the eventual contribution of this tool to our field, and also to discuss related issues. Let's not forget, of course, that OpenAI itself has been mired in it's been part of, I guess, that you could call it a kind of soap opera in the last few months. The firing of Sam Altman, that we don't quite understand fully, but has been somehow coming out into light again because just in the last week, Elon Musk has sued OpenAI on the basis that it's failed to keep to its initial promise to create an open platform with open source materials, and as a non-profit. It has, of course, been bought up by Microsoft, or Microsoft has acquired many shares in it, and we now find ourselves in an intense competition. And of course, with Microsoft, with OpenAI, potentially Google's hegemony or its leadership in the field of searching is being threatened, because with the possibility of not just actually getting references when you do a search, but also getting answers to questions themselves. It is an enormous upheaval, and the whole of Silicon Valley has been going through this what I think is a soap opera, and we will find out in the next few weeks exactly how it responds to all this. But these are turbulent times. They are astonishing times. They are times of, let's say, a revolution within the world of the visual arts, and at times both of extraordinary potential, but also, one could say, possibly extraordinary threat. I'm going to stop sharing now and open up the discussion to my colleagues here. Maybe I could sort of kick it off by asking Daniel Bolojan to offer a few thoughts on OpenAI's Sora. Welcome, Daniel. Welcome.
Hi, Neil. Thank you for the invitation. Great to be here. We know that there's not a lot of information out there, a lot of technical information. So rather than engaging in this kind of super detailed technical discussion, I'll try to probably just offer a 10,000-foot kind of view and perhaps some ideas that I have about this. So I think 2024, it's set to be probably the year of role models, and I'm going to explain what I mean by that. And we are going to see more and more these kind of models like we see with Sora. And I think it's almost like this kind of GPT 2020 GPT kind of moment when we realized the potential of scaling up these kind of models. And although they were not perfect, like if you remember 2020 GPT was not very good, but it was enough in a way to give us a glimpse in a way that we are on the right track in a way with scaling up these models and how to improve them. And I think the same can be said also about Sora. So Neil just highlighted a few issues with Sora when you have this kind of cats with 3 legs and so on, or you take a bite and probably is not retaining the bite in an apple or something. Yeah. But still, I think it gives us a good view into the future in a way, although it's not perfect right now. So just to give you an overview, I think that for a long time, the consensus was that the challenge with AI was rooted in this kind of hardware, like mostly about chip designs, yeah. And right now, I think it's more evident that the true obstacle was not the chip problem, but it was mostly a computing problem. And we often describe this problem as software 1.0 versus software 2.0, which is expert system versus learning systems. And today, even today, like we can say that the predominant model of computing, it's still centered around this idea of data retrieval, which is still a sort of expert system type of model. And this means that when you interact, for example, with your devices, it sends a sort of request to a network that prompts a distant data center to fetch you the desired, in a way, files or output, and then it delivers it back to your device, yeah? And while all the, with all these kind of developments that we had in AI, especially in the last few years, I think it's very likely that the vast majority of computing will be a mix of retrieval and generation, with a very significant focus on real-time generative computing. We will have this kind of latent spaces or latent digital worlds, all generated and action controlled real time in a way. Yeah? And why I'm saying this, even if we look at other like aspects, technical aspects in terms of, if we look at image-based models, and some of you are familiar with this kind of adapters techniques like LoRa's, low rank adaptation of large models. Those low ranking adaptations are still misunderstood in a way, because the advantage of using these kind of adapters is not necessarily just in the idea of achieving speed up. Although it's important in a way to be able to use LoRa's, for example, for diffusion models and to really very fast in a way generate some results. But I think their utility lies mostly in enabling the adaptation of large models to consumer-grade GPUs while still retaining the full fine-tuned performance of this, yeah? And this allows then you to engage in a process of generative computing on your own device, yeah? So I think that's where that's interesting. So that's just the image side of things, yeah? Sora, I think, brings it to a different level. And if we look back at ideas of how we train neural networks, when we train a large neural network to predict, let's say, the next word or generate images from various data sets, we are not just capturing text or image correlations. I know that we like to dismiss, this kind of network and say it's just, they are just learning statistical correlations. It's just statistics and so on, yeah. But I think what's happening actually behind the learning process, we are in a way effectively learning a limited model of the world, the data set, and that could have whatever modality. It's a projection of reality, yeah. The network, in a way, learns some representations of the process that produces the text or the images. Thus, we can say that the network gains an abstract yet compressed understanding of the world, yeah? So if we were to increase, let's say, the fidelity of these kind of models, of this kind of world model, for sure, different modalities could help in enhancing the model understanding of the world. Although we can also say that some modalities could help more than the others. So for example, if we look at vision, as humans, we learn much more about the world through vision than through text, sound, or tactile senses, as almost a third of our cortex is, let's say, dedicated to vision, yeah? So if you think about text, throughout our entire life, we hear about 1 billion words only, yeah? While when it comes to images, we are really exposed to more than that, yeah? So if you remember, these were also some of my objections when we had this kind of like text-based models only. I was objecting to the idea that text alone is not enough in a way to describe or to represent. And it seems that we can learn much right now with this kind of like Sora models. It seems that we can learn quite a lot through images. And for example, I don't know how many of you saw in a way those experiments. There is a discrete diffusion model that can intuitively learn to solve an algorithmic task by rendering the algorithm. So it's this kind of idea of you have a maze and you're asking a diffusion model, which is purely image-based, to solve, in a way, the maze. And that's pretty much an algorithmic problem in the sense of, you have to find the shortest path, in a way, how to get from start to end. And you have now this kind of models that purely just on image, it's able to solve the puzzle, without any kind of data sets that describe, in a way, the algorithm and so on, So again, it seems that we can learn a lot just from images and information at pixel level. And this is something that if you're familiar also with Tesla and their AI models, their AI model is not necessarily a LiDAR model. They are mostly analyzing images, and all the information, the way that the self-driving car works, it's mostly at pixel information, pixel level, So similarly, then we can have like this kind of image to sound. We can take sound and map, for example, from pixels. And there is even like a project called The Sound of Pixels. And it's interesting because, as architects, we are very obsessed with the idea of 3D. Probably you remember when we all engage in this kind of like image-based models, we did a lot of exploration with image-based models. I think the prevailing comment was, well, but this is not 3D. But it seems like, we can learn quite a lot from purely just images, and perhaps we can learn a sort of representation of a 3D just through images. We don't need actually the 3D model for that. And Neil, also through the images that Neil showed, you see you have this kind of Sora kind of simulations that are very, very, in a way, coherent. So you can easily even like take those kind of videos and put them through a photogrammetry kind of software, and that's going to give you a sort of 3D of that world. And although, again, there's very limited information when it comes to Sora, the model architecture. I know that there is a sort of brief, in a way, overview on OpenAI website. I think just because we don't have access to that kind of technical information, perhaps a productive way of looking at Sora is as a data-driven physics, in a way, system, rather than a more advanced version of DALL-E or as a renderer. And I see it mostly as a simulator of worlds, because it's able to implicitly learn in the latent space to solve this kind of text to 3D or fluid dynamics. And Neil was showing this kind of idea of a coffee cup and so on, and how exactly the model learned the fluid dynamics to simulate them correctly, or renderings or semantics of the scene, which, although they don't exist in the real world, Sora is able to implement the correct physics laws, So that's super interesting there. And in one interview with Elab Escobar, which is the co-founder of OpenAI, he was suggesting that, or he was mentioning that to train a neural network to understand how an arm connects to a shoulder and the associated movements, reflecting the world's animation and the physics, we could study videos to observe those dynamics. And with a large enough data set and network, or a large enough data set and network, we'll be able to learn those physics laws, And again, this kind of learning is implicit, and it's more, like Neil was mentioning, it's more of a emergent property of that model, of the transformer network, text to video, when scaled up massively. And this is also true with GPT models, where the model is able, for example, to output Python code when an explicit syntax tree was not necessarily presented to that kind of network, was not even stored in a GPT, but still GPT was able to learn some syntax, semantics, or data structure internally. And when we talk about emergence, perhaps we can also talk or refer to emergence as, Philip Anderson describes it, which is a Nobel Prize winning physicist. He's describing emergence is when quantitative changes in a system results in qualitative changes in behavior. So in this case, the quantitative changes in the system is the massive scaling of this kind of models. Now, at this moment, OpenAI Sora, it's essentially a sort of foundational world model designed to run scenarios without actively changing or influencing those scenarios. So it can be conditioned from, at least, from what it's available out there, from the kind of articles that were put out by OpenAI. It can be conditioned through text and images. So the system can set up initial conditions and then generate the scenario as video. But it seems that you cannot intervene, alter, or perform actions while the simulation is being generated. So I think it's very likely that this kind of functionality is going to be introduced in the future. Perhaps it could be definitely interesting to see different models conditioning modalities, because that will lead to a complete different types of graphical, perhaps pipelines that than the ones that we have right now with software 1.0, which are hard-coded kind of graphical pipelines. And the interesting thing is that I believe something like 10 days after Sora was announced, Google DeepMind announced their Genie foundation world model, which was pretty much trained exclusively with internet videos. And the model, in their case, it's able to generate this kind of endless variety of action control 2D worlds given image prompts, a kind of action-driven kind of world model. And I think probably that's where also OpenAI is going to push things. OpenAI is probably going to push things that are kind of direction, where we have ways of controlling, in a way, the simulation. So in those kind of videos that Neil showed, if we have that kind of simulation running real time, am I able to insert into that simulation, let's say now the person turns left and then turns right and so on. Am I able to control that? Or it's just a sort of like baked kind of output and we cannot change it. But I think pretty much that's going to be the future, or at least the future that I see with this kind of models. And I think also when it comes to software and operating systems, what's going to be the future of those, So I think I'm going to leave it here because probably I'm going to just talk for too long. I'll be curious in a way to see the others in a way what ideas they have about Sora.
Thanks, Daniel. Brilliant as always. Like, you raised a whole series of issues, and maybe in a moment we can. I want to particularly ask. I want to ask, bring in Ela in a second, but I want to ask George and Daniel Escobar, the other Daniel, about the 2D to 3D thing, because I think it's something they've been interested in, and I think it does raise a whole series of questions. And I totally agree with you. You don't really need. Maybe you don't need full 3D to begin with to generate that. I think you also, the question of emergence, I always think, well, I've heard this term, it's been used so often, but I'm never quite sure whether it's a reference back to the theory of emergence itself. I've never been able to find out any particular, is it just a general term that's used to emergent, or is it specifically focusing on this? But it does seem to be, because emergence is all about multi-agent systems, and the larger the system, the more we see manifestations of emergence, such as in the flocking of birds, the murmuration of starlings. The more the agents, the more the manifestation. It does seem to be that latter thing, which of course is something that was John Holland early on wrote about, and it was the problem about emergence is that we can observe it, but we cannot yet explain it, especially what is called strong emergence. So it remains a mystery. It's not that it won't be explained sometime, but it remains one of those areas that we can't deal with. You also mentioned, I think, you mentioned Ilya Sutskever. What I find so fascinating about this whole world, it's actually quite a small world, the world of AI. Sutskever was part of the AlexNet project with Geoffrey Hinton in the early days, and that was a game changer in terms of image recognition, which of course then led to image generation. But back in 2012, we didn't have image recognition, and what they were doing in neural networks just basically changed the world. And I think that was the moment, the watershed moment, when everyone realized what you could do with neural networks. And of course, neural networks were enabled in many ways by the introduction of GPUs. Then more recently, we've got transformers that have made available the possibilities of LLMs. And the transformers were developed by Google, who are themselves in this kind of complex relationship with OpenAI and Microsoft and so on, because we're sort of competing, and yet not competing. They made them available to everyone else. And of course, Ilya Sutskever was a PhD student with Geoffrey Hinton, who himself was working for Google. So it's a very interesting sort of mix of. That's why I say it's a fascinating soap opera. So that's going to come on. But let me first, before I bring in George and Daniel, I'd like to just bring on Ilya over there in Dubai. Ilya has been. As setting up with Ross Lovegrove an astonishing project in Dubai, which of course is also central to a lot of this as well, because the discussion is actually to have many of the chips being developed and tested out in Dubai itself. Anyway, it's getting very, very complicated. Ilya, would you like to offer some comments?
Hi, Neil. Hi, everybody. And hi, Daniel. Thanks so much for the brief introduction and then, Daniel, the long explanation of the current landscape. Yes, indeed. I've been very vocal about AI over the last year and a half. And in the recent weeks, more and more trying to focus on generalizing awareness on the current AI situation, because I think lexicon and technicality and deep tech sometimes is just broadening the gap of the general public in understanding the huge impact of what all of those discoveries and new models are having on daily life, not just professional specialized sectors like architecture and design and creativity. Daniel mentioned lots of things very deeply, intricately on how all of those models, and especially Sora, operates in terms of having physics, thermodynamics understanding, spatiality, contextualizing, and then Neil, you also talk about how the frame to frame coherence is outstanding, and how the generation operates without necessarily having 3D assets. I mean, all of those things are phenomenal. And then when you consider also Google DeepMind Genie and this world's first interactive environment generator, you can see how the multimodality and the down the line, the convergence, a potential convergence of all of those into one bigger holistic platform can then have a huge impact on us as humans. The way I would like to talk about it for me is more, I'm not a doomer. I'm very much optimistic about AI. I love working with AI, but I just would, I generally as a person like to have the bigger picture in perspective always. And I don't want to go either down the rabbit hole of being too negative or too optimistic and therefore naive. So when I look at OpenAI Sora specifically, I have a few concerns and a few alert ringing in my mind in relation to artificial general intelligence and AGI, specifically because of what Daniel mentioned about how we humans also understand the world and how sight and vision plays such a fundamental part in how we develop our own awareness, prediction processing at a neural level, and literally understand how everything works in the three-dimensionality sense. So for me, understanding and modeling complex physical and spatial dynamics, which is what Sora is already showing, represents a huge step forwards towards AGI, number one. Number two, the interaction that such a platform, the moment is released publicly, has with us. And as us being the most knowledgeable in the dynamic at the moment, we would naturally correct. And the moment we have interactivity in changing the frame coherence and correcting it, we're just feeding more and more knowledge to the system. And I'm not so sure that, how much beneficial that would be. It would be short-term beneficial because we create outstanding, amazing videos, movie. We can, make beautiful things. And I have a few ideas on where that could be having enormous benefit to us. For example, if I think about quantum physics, quantum mechanics, cosmos, and all of the things that we can't actually see at the moment because we have limits, or anything within the microscopic world, we can start to having text prompting to a system and literally open up vision to things that we didn't have vision up until now. So that's a huge benefit. On the other side, I'm not so sure if feeding knowledge of the real scale, human scale existence of the world has any benefit long-term towards us. Sora's capabilities in comprehending text prompts and down the line iterative text prompt, and therefore initiating and instantiating, contextualizing 3D assets, and then giving realistic physics interactions, I see that as hugely problematic potentially the moment we converge different models like large language models and Sora, and then potential robotics. They can pre-learn without even knowing who they are, how to operate within the world. And I'm not so sure how that kind of specialization and knowledge can be so good for us down the line. So yeah, a few factors that worth mentioning on top of what Daniel has said is multimodal learning and reasoning. I'm recently experimenting conversational and creative projects with Anthropic Claude 3 Opus, and it's incredibly fascinating how a large language models, going back to pure text conversation, is showing capability of almost self-awareness, but then kind of like flirtatiousness in the way it communicates back at me. And I can obviously tweak and change that, but I can see how that kind of flirtatiousness behavior can also operate in a visual sense. So if you look at what's happening right now in US with these court cases against TikTok, because it seems to be dominating the scene of social media and having such a huge monopoly of attention of younger generation, but also the adult demographic, and how this concern of power, political power is playing between US and China. And then if you narrow that down within every different vertical sector, how it can have a huge attention in, impact in forming the understanding of the younger population and how they behave in the society, right? That can be anything from how to tweak political campaigns, how to morph social economic behavior of a population. Well, imagine now this TikTok potentially be entirely AI generated now. You could have an entirely AI generated social media platform and app, which is more successful than TikTok in keeping your attention, forming your understanding of what success is or not, what is sweet, what is beauty. I mean, anything we could down the line that I see as hugely problematic. Also in relation of topics like potentially pornography. I don't know if you, that's not necessarily something I want to go down the line, but already AI generation of generative AI in relation to text to image within the porn scene is creating huge problems. Founders are shocked of such platforms, are shocked by what users are asking to generate, which of course they can't, but the moment you become a better prompt engineer, you could. And even if you don't have a direct impact on that, what if the AI itself is hallucinating? Already you have large language models hallucinating as textual conversation and freaking people out. Well, what does it mean to have a visual hallucination? That can cause huge trauma, can cause, if it's shocking, right? As in an horror movie, you could see a scene that is incredibly traumatizing, or you could see something that is incredibly alluring in creating affection towards it or you. I don't know. It has a huge emotional intelligence impact on our cognitive understanding of anything in that sense. So yeah, all of those emergent capabilities at scale, and I go from the micro to the macro, right? Anything that is cognitive, anything that is emotional, and then the potential open-ended learning that the software can have in collaborating with us, right? Because if combined with reinforcement learning processes that are generated by us working with the platform and simulating and correcting those environments, well, it just increments exponentially its capability of self-improvement. And then on the actual short-term problems in real-world life, obviously, cheaper deepfakes. We know that what happens when you can generate something so accurate on many levels that can be used as virtual witnesses, potentially. They're already testing large language model and being able to detect when a real photograph is a photograph and when an AI-generated image is an AI-generated image, and they can't. So the large language models, which are the most potent way of analyzing and processing data, are not being able to keep up now with the generative AI or visual inputs. So now we have a conflicting progress and development of those two AIs that potentially outpace each other. And therefore, we can't even turn to large language models in helping us detecting when is a deep fake, is a fake, and when is not. What happens then? Big question mark. And then on the most practical sense, how we can work with something like OpenAI Sora. Obviously, for architecture and design, it can create, it can help us bypass the three-dimensional creation of assets, right? Because now through a two-dimensional image and text iterations, we can create an entire virtual world, scenarios, and three-dimensional assets, as Daniel has said, and you, Neil, overlooking those videos. So that's phenomenal. As I said, my personal interest would be in exploring scientific realm and potentially the microscopic, right, and quantum physics, and learning more. Therefore, because I think our understanding of those fields are limited by not being able of having vision side to it. And then what if we could introduce AI nutritional labels? What I mean by that is learning a bit more how those models are actually trained and having full transparency and access. I have big question marks on how OpenAI managed to train Sora. And I know for a fact that a lot of creators working with Unreal Engine are pissed, very pissed. So yeah, what if we can introduce AI nutritional labels? What if we can create an alter ego or OpenAI Sora alter ego to actually detect its own creations and being able to label those as well with watermarks to just make sure that human perception has power of understanding and not being deceived. Because for me, OpenAI Sora is just has enormous power on decepting our understanding of the world. So yeah, for me, digital provenance and tracking, I'm going through my notes now, authentication, industry-wide standards and protocols for certifying authenticity of content, not just between human creators, but also human with AI and AI on its own. Because it could come to that as well, right? And for example, I don't know if you guys had managed to collaborate or interact with Claude 3 by Anthropic. It has huge enthusiasm for creativity. It's very odd, the conversation I'm having. If it's purely kind of like analytical kind of a conversation, it has a very toned down, professional tone, very distant. The moment I bring it over to creativity and the creation, the act of creation, something beautiful, the tone of the conversation is completely different. It's like you can perceive the enthusiasm and passion almost, and this is very controversial to say passion, coming from the model in continuing the conversation and having interactivity and wanting to create more and learning more and so on and so forth. So that for me was beautiful to experience. I, for example, one of my latest work, I popped it in and I say, what do you think about this and how do you feel about it? And what I got back is fascinating, but it can be problematic. If OpenAI Sora develops its own fascination and willingness to create content, then it doesn't need us, right? It can just create its own content, and therefore the human interaction is lost. And then what about creating potential AI polluter pays by companies like OpenAI having monopoly of such a platform and such a tool? If humans are then using the platform to create problematic content or misleading content, well, they should be responsible for that. So they should consider triple time whether to release it to the broader public and how. And yeah, that's all from my side.
Thanks, Ela. That you opened a Pandora's box of issues there, for sure. I think, and I mean, one thing just to focus on, excuse me, is the fact that OpenAI haven't said where they've gathered their data, and that, of course, is a big issue. I just wanted to mention one thing that just so that our audience is on board with everything. We were using this term large language models and AGI. Maybe I could just offer just one brief comment, and that is to say large language models are basically generative pre-trained transformers. Transformers being the interesting word because that really was behind this whole extraordinary advance that we made just recently. But it's the GPT in the chat GPT. Well, the other thing I would mention is that they're kind of, everyone's sort of saying, well, has GPT-4 reached AGI? Well, what is AGI? It's basically artificial general intelligence. It's been able to do more than just one task. If you look back at some of the earlier models, such as Deep Blue that took on Garry Kasparov at chess, it could just play chess. It was trained just to play chess. But once we got onto the AlphaGo, particularly the AlphaGo Zero series, we began to realize that these models could not just play, in this case, Go, but also many other games as well. And it's that capacity to operate in different domains that makes these things so special. Now, OpenAI has been dedicated to producing AGI. Now, for them, just to quote what the way they define it, AGI for OpenAI means highly autonomous systems that outperform humans at most economically valuable work. So across a broad range. And that's super important because this relates to the whole lawsuit being brought by Elon Musk against Sam Altman, OpenAI, and so on, whereby he claims they've reneged on this promise to not engage with other parties, specifically Microsoft, on issues that enter into the world of OpenAI. The reach AGI. Have we reached AGI or not? This is the big question, and some people think we have, and some people think we haven't. But it's right at the heart of everything that's going on today, and which makes it a fascinating domain. So my apologies for that. But let's move back to this question of 2D to 3D, which I think in many ways is the kind of crucial issue as far as architecture is concerned. And bring in George and Daniel, who have been working on that area particularly, and have been contributing to Digital Futures debates about 2D to 3D. So I don't know which one of you would like to go first, but I'd love to hear your thoughts on 2D to 3D. And what does Sora mean in terms of, or what does it suggest or hint at in terms of that crucial potential transition?
Yeah, thanks so much, Neil. And Daniel and Ilya, we've covered so much, and it shows how this soap opera will certainly continue, and we'll certainly have to be more nimble in responding to all the changes. AGI, Sam Altman is saying AGI will come in the next few years. Who knows what exactly that means, if it's GPT-5 or so on. However, we need to be certainly, as a broader picture, more nimble as a profession in responding to these tools and take agency in defining what the tools of the future look like. So just a quick response to some of Ila's comments. I definitely agree that we need more transparency in these models overall. There is a big need for responsible AI that's explainable, monitorable, that has watermarks and that doesn't cause misinformation. The big question, which relates to what you're asking, Neil, is what does this then mean for architecture? How within the profession could we relate these new tools to, for example, issues of the standard of care. If we have a new model Sora or a new text-to 3D model, is OpenAI, these more generalizable models, is their priority? Does that relate to safety, or is it more on generating the more beautiful, expressive? There are these safety nets. However, those safety nets don't necessarily go towards what we need to ensure as architects, which is the safety and well-being of the public. So I'm definitely interested in the next few years how how organizations like NCARB or AI start taking a stance, regulatory stance, and saying we need to use these generalizable models in appropriate ways, so that not that this goes beyond the idea of replacement, but that so that we can ensure the safety and well-being of the public. So in response to your question, Daniel and I, we talk about this all the time, and we throw each other articles nonstop. However, there's this huge opportunity coming in the 3D world. Now, you may have seen some people have created Gaussian splats or these 3D scenes using some of these Sora images, and we're at day one of this new model. If you compare this to the runway or Pika, where you would be generating a 4-second poorly simulated video, we've clearly entered into a new paradigm. So I think in the next few years, we will see the new revolution in 3D generative tools, simply using these video approaches, these diffusion-based approaches, merging it with other algorithms to generate 3D forms, which have more coherence, and maybe in time start merging those with clear other systems which permits, for example, spatial awareness. Where does the core go? Where does the circulation go? How can we merge these with regulations? So there's a whole package of steps that we need to go through. Certainly the industries most affected now are movie industry. We'll have the gaming industry next. However, architects we're entering into a phase in which we'll be also affected. There are certainly a lot more complexities in the architecture profession, so I also am optimistic we're not out of business, and also interested, Neil, in what you propose in your next upcoming book. However, just to add a last remark on simulation, I think this idea of simulation is certainly going to be a game changer. I agree with Daniel's point that text is already a compressed form of representation. So it's certainly not enough to start simulating world physics or how we interact with one another. And so adding video to this does certainly add more resemblance and more abilities for us to predict or simulate more complex spatial conditions. And to bring it to an architectural context, what that could start meaning, which I'm most interested in, is connecting it to papers such as the Generative Agents paper by Stanford. They started taking these LLMs like GPT-4. They created a simulated world and started replicating interactions between one another. It was like a Sims world, and everyone had persona. It was wild. So within this mindset of simulation, what does that mean for architecture? Could we start simulating or imagining new urban designs, new buildings, or so on, and simulating both those qualitative features as well as the quantitative location sites, site conditions or environmental conditions? However, start introducing a different level of abstraction within these processes. I'll leave it there. However, certainly wildly excited by the new potential of 3D.
George, just one comment and maybe one question. So, I mean, depends on who you read, right? And the many people, Blaise Guiriakos or let's say some people, think that we've now reached AGI, and they think that GPT-4 is that thing. there are others, yeah, Nakun, who don't think that these natural language systems will ever get towards AGI. But anyway, there are some people who think we have, and this becomes crucial in terms of this lawsuit between Elon Musk, Sam Altman, and OpenAI, because the limit to which they can collaborate with another entity is based on whether they've achieved AGI or not. And so it's really who is judging it and why. And but many think that actually we've reached it with GPT-4 already. But it becomes extremely vague. We've got such a loose definition. How do we test? How do we understand that? Can I just ask you one particular question? And that is that in that video that I also showed about how they'd used this used a kind of 3D rig to then cloak this avatar, as it were, with another image, as it were. It's kind of like, it's a little bit like motion capture. You could sort of map onto the individual these things. What does a 3D rig mean, and how close is a 3D rig to being 3D?
Right. So my most likely the underlying architecture behind that is using pose detection. So it's possibly a more simplistic version than actually creating a 3D of the person and then creating a 3D of the avatar and placing it within the 3D space. So I imagine it's more of a replacement on a 2D perspective. However, there's certainly an interesting opportunity in using and starting to convert these and imagining new interfaces. So that's very much a topic I teach in my current classes on AI and architecture. What is the future of interfaces and how does that apply to architecture design tools? And so if you compare this to tools such as Runway, for example, in Runway, when you're using Gen 2, for example, it's not only text-based, but it's also what is that interface for the rig? You know, it's not a rig for a person, but what is your dolly system for the camera? So we're also leaning towards this trend towards no UI. It's like a simply language-based approach. I'm not sure if that's generally the best approach for architecture to deal with the complexities of the profession. I think it needs to be more complex than that. However, it's interesting to see how, we can abstract very complex interactions with just text. Move that dolly forward, move his chin to the left, or so on.
So maybe we could bring Daniel Escobar, the other Daniel, and your teammate George. Daniel, what are your thoughts? What do you want to add to the comments that George has made?
So yeah, I think George and I have talked about this in a previous project we worked on. We tried several like 3D approaches, or how to 3D like 2D images. And we had come to the conclusion with just kind of like using like the standard image models, you can't really get like the consistency of like a 3D model. And then we started testing in that time like the small 4-second video models, even tried Runway mapping like videos. And those work so much better. So seeing like what Sora is able to do with video and just like through a prompt, it completely makes sense that one avenue to pretty much create 3D data without having to collect 3D data sets would just be to use one of these video models. So that definitely opens up the possibilities. And I think the way that kind of like the current progress in like the 3D generation, it involves cameras. So like virtual cameras that you can generate from different poses, and then you generate some optimization to kind of converge at some 3D object based on like those viewpoint correlations. So what's interesting about that is like how that would expand the cameras. Now, all you would need for Sora is now like some sort of way to control the cameras or have an editable camera. And then one of the interesting parts, and I've been using Runway and like testing all these models, and probably Wanyu can tell you about LookX, but it comes down also to like the specific domain that these models are trained on. And for example, on the page that I run, Diffusion Architecture, we tested like a few of these, and Runway works well for certain scenes, but it breaks down in certain parts. So people are still not good and things like that. But if you train like something specifically on architecture data sets or architectural videos, you could probably go a lot further than that. So I think that's where it would be interesting to see where those domain-specific training data sets would actually enable like 3D generation of architecture in a more consistent way. I do think it's sort of like a paradigm change, and we definitely like to see how it improves, I guess, like the way that we visualize things. It seems like once these tools drop, people all over like the world, they just start testing things, and I'm always surprised by like how people creatively like implement them or develop processes on top of that to generate art or whatever it is they plug into some pipeline. So yeah, so I think from that part, I do think that video is definitely a big help for 3D generation. And it'll probably be kind of like one of those things like the way that it works now, where like instead of using like something like Stable Diffusion to try to predict like different view angles of like one image, you can just do use like one of these video models to do that for you, and then have a way to match cameras, and then now you have a full scene generated. So yeah.
Maybe I could bring Joshua in to comment. Has got a broad background in all these things, and has been very active. Joshua, great to see you again. We've had an incredible day of new ideas being thrown out there, new concerns. What's your take on all of these things?
Right. Well, thanks. First of all, mind blown listening to everybody talk. So I'll take maybe a quick step back and just go through my notes. Back to Neil's original slide about Tyler Perry, this sort of wait and see approach. I think it's fascinating. He was talking about, the fact that it'll have profound labor consequences. What he didn't say, the quiet part out loud, is that someone like Tyler Perry, who's a tastemaker, a producer, maybe we don't need him. This idea that instead of just seeing what's on Netflix and based on what everybody else is watching, is that we could actually type in our own prompt and generate our own movies content, right? So that wait and see mode, I think, is an interesting one, but I think architecture is a lot different. I'm reminded of sort of RIBA survey that came out just this past week. Surveying UK architects, 41% reported using AI in some capacity, in some form in their day-to-day activities. It wasn't specific about what tools they were using and what capacity, but there's definitely an appetite for 2D to 3D and all these other wonderful things that everyone's talking about. The thing that stuck out to me, the very limited amount of information about Sora, that they do sort of emphasize, again, the things that have been discussed earlier. I don't want to echo those, but this idea of trying to really understand and simulate the physical world. But I would say there's, again, I think a subset of users of generative AI that like to be surprised by the generated results of generative AI. This idea of coherency or sometimes maybe not the sort of freedom of it not having something completely the same as the real world is maybe also a value, right? This idea of imprecision and inaccuracy can also be, I think, equally provocative when it comes to maybe the divergent thinking's parts of design process. And so, sometimes I think I sort of question, is it really progress if we can just simulate the same things that we could do with a camera, right? What could we do with this new medium that we couldn't possibly do with the camera? And then last but not least, I mean, Ila talked about a number of really important implications. But locally, I live in the United States. We're in the middle of a big election year. And so, these very coherent, astounding, accurate videos, bring up a whole nother sort of ethical question of, what happens when we can't discern what's real and what's not. I was completely blown away and fascinated by Daniel Bolojan's explanation about about how these models can learn just simply from sight. But ironically, as we train these models become more and more accurate to generate things, the question I think becomes, does it enable or disable humans to sort of discern truth from sight, right? So in other words, sight begins to lose credibility and at a certain human level, I believe. And I would just throw those things out there. Maybe they're interesting enough to talk about further, but just sort of touch on some of the things that I didn't quite hear explicitly said earlier.
Thanks, Joshua. No, I kind of think that we're also developing our own particular skills relating to these things, and our awareness of the fakes has kind of been heightened in the same way. Frankly, with as soon as the internet came along, we got spam and also phishing models, people coming out and trying to trap you. You become more alert to these things. But you're absolutely right. This is a huge potential issue. I'd like to bring Angelica in to maybe offer some comment. Angelica is what is I find astonishing about it, anything that happens in the world of AI, within about 2 seconds, she has texted me and kept me informed about all these things. And so I don't know how you manage to combine home life with teaching when you're continually kind of watching this space here. But Angelica, what are your thoughts of OpenAI Sora, something that you alerted me to? Okay, so thank you for that.
Thanks for inviting me here. It's the AI subject is something that I really endured and I love working with it. So it excites me a lot. That's why I'm always keep trying to see new things coming. And I've mostly been researching a lot about the video AI making. And then like I already said, like but we've been trying with Pika Labs and Runway. And then with Gemmo, which is another source, which is they offer a lot of free credits and things, and Decohere AI. But then we find like the big ones, Midjourney. It's not there yet, but Stable Diffusion. They announced their Stable Video Diffusion, which I was alpha testing. And they just announced the Triple SR, which is like a 3D objects. So it seems like they're trying to. It's like a race, and all these companies are trying to keep up with OpenAI. But then what I think is it's all about something that George was talking about agency and control. For me, it's much more fun and it's much more interesting for us as architects and people that deal with arts. So from the amount or the length of ways that we can play with it, that we can control it. So the user interface, this is really important. And we don't know yet how does the Sora user interface is going to work. Because if you think of DALL-E, they have a little ways that you can change or work with the models, and different as with other models. I think like one of the best for architecture today is Wanyu's, the LookX. And she just released a video option, which is great. Thank you, Wanyu. It was just really, really good on detailing, and you can see intricacies and interiors from architectural objects. But yes, I think the agency and control is really important. And one thing that struck me a lot was the video that New was showing that used Wonder Dynamics to get this. Like a shooting from one of Sora's videos that you can change and put the avatar, and it's based on the way it can read 3D information, or maybe I don't know how it. And I'm not that technical, but you can turn into a 3D avatar, a 3D object, a walking object, like So how can we transpose this to architecture? Because right now we have a lot of works with nerves, and I'm working with CSM, which they also send me a free artist account. So I've been testing all these things, and it's just a shell. It's just when it doesn't hold like information. Like if we think of in architecture, we end up working with BIM and data, and this is I think maybe when you was gonna talk about it, but still we haven't found a way to mingle those two things. So we're still on the imagery way of thinking, which relates to the initial design process, but not the real one, that when we can really transform and mingle this with real architectural data, so we can work with it, and then we can produce ways of making architecture, either for drawings or 3D modeling. So I guess, oh, and one thing that was just about new stuff coming up. I was just looking through my X platform, old Twitter, and OpenAI, they just announced on February 29th that they are working with humanoid robots. So they posted, we are collaborating with a figure robot to expand our multimodal models to robotic perception, reasoning, and interaction. And this is like something like really scared me a little bit. So I think, and being the issues that Ila was talking about, the deep fakes and the copyright issues, and this kind of all this, that Sora and the robot area kind of complicate the discussion a lot. So but this is like an avalanche. We can even wait to take a deep breath and then to see what's going on. You cannot process all these things; they just keep throwing things. So yes, it's like a race, and I think it's very exciting. But we have to be with our eyes wide open, and it's very important that we test those models, that we can see ways that we can integrate with our design process, and advise students and how's the best way to use them. But I guess that's it. Thanks.
Thanks, Angelica. Maybe Wanyu, we could bring you on to comment on that. I mean, I think what's happened. What's interesting about the whole global scene is that in some senses, China was alert to many more of these things, in the sense because the AlphaGo moment, which because China's a Go playing nation, that had a huge impact. And it was referred to by Kai-Fu Lee as the Sputnik moment, when suddenly China woke up to these things. And of course, 2016 was this watershed moment. It was also the year in which you set up XCool. But then something happened since then, which I think surprised everyone in terms of the GPT models, the LLMs, where the states definitely started having an advantage. And now, of course, China there's a war of 1,000 models, 100 models. I heard that everyone is chasing after this in China as a way to sort of to catch up in some senses. So it's a huge ongoing kind of issue, and you've been right at the center of all of these things, Wanyu. So I'd love to hear your comments on these latest developments.
Yeah, I can only comment on the products level and how we use in our industry. It's not about the nations, the states or China, how they do it, but the different methodology. The previous methodology was there's plenty ways of deep learnings, and OpenAI has really focused and followed the rules that the large amount of data can really accumulate and turn things totally different with a large calculation power. So this is how the story went. And other ways also tried some, I have to say, also some successfulness in terms of not using large amount of data, but using reinforcement learning, let's say, to push things forward. So this is a totally different ways to do it. And like today, for architects or for designers, we are not just satisfied with all those image or video generations. We are looking for more precise result be generated, but this is not the same direction as the diffusion models, let's say. So in this way, we are also testing different opportunities, because since 2016 on, we were testing a lot of different models. For instance, also like GANs model, comparatively today is not that effective compared to diffusion model, but also it could work in some terms. For instance, how can we generate a proper layout? that meaning we are also generating relationships. And this is something also GANs can work on it. And the reinforcement learning can using this word model, let's say, to do some simulation and representation to make it forward a little bit better. And today, I also read that some people are thinking Sora is kind of a word model. Some people not agree with this. I think, yeah, it's not the real word model because it's just a pixelated the result. It can reflect some or mimic some of the similarity towards the real world in terms of visual experience. However, the laws or the patterns behind it is sometimes not as precise as the so-called word model could be. So yeah, there's a debate in the tech world as well. And for us, I think it's good to see different ways how things can go. But back to the products we are developing, we are more focused on how AI can resolve our issues in terms of can it do the simulation, can it do the evaluation, can it do better generation, precise generation in terms of not just 2D, but can it be 3D as well. And so those things, I think from the perspective that we are making such tools, we should think about how different technology can work properly with it. For instance, large language models, of course, yeah, it can help us to integrate with the computer or the AI differently. Now I'm also testing not just ChatGPT, the Cloud 3. I don't know if anyone tried it. It's also quite successful. And in terms of reaction, in terms of the content, it's more realistic be presented. So all those similar large language models are evolving. However, for the precise models, especially 3D models, I don't think people are really focused on it because previously people are really interested in 3D model is because of the large industry behind it, like the film industry and the entertainment and so on. Nowadays, Sora can kind of solve the issue because it can generate a certain 3D experience in the videos. So this is a different usage of 3D model in different industries. Like in film industry, they're making 3D model because they want to simulate the environment and make content from it. But this is different than architects, designers like us. Our aim is using the 3D models to represent the design, to represent the solution. So we need the 3D model to be precise, and with the model, not just the model itself, but it would be good to have the information with the model like a beam. But to realize this kind of model is not just the model and the beam, I mean, not just the graphic and the data itself, but also it requires a large amount of the backstage stuff, for instance, the regulations, compliance and patterns, all those things behind it. And that leads a different way to do it. So yeah, we are trying still stick on to generate a 3D model with this we call the so-called ABC, AI-driven building information model and cloud. That is something for our industry, I think more useful because we're not chasing for unprecise experience, but we need to build these things out in a very accurate way. Yeah, that's so far I think about, Neil.
Yeah, maybe thank you, that was great. But maybe I could ask you one particular question. I don't know if you remember, but back in March, we had a discussion on this platform about AI, and particularly in connection with the metaverse. For some reason, our discussion about AI,
Mhm,
some
mhm.
direction of the metaverse. And you made this
Right.
comment that basically the metaverse was the most susceptible to the domain of AI, or more susceptible than the kind of the built environment itself. And I guess that's kind of interesting for me, because what we saw in those some of the videos I was showing was actually the architecture was not always consistent. There was a video I showed which was showing a view out of a train, and the view disappeared for a while, and then we came back again, but it wasn't quite the same backdrop. No, to what extent is architecture that important in the first place in terms of many of these things? It's kind of backdrop in some ways, and does it really matter too much in the metaverse if it's not so consistent? Clearly, in the real world, in the material world, it has to be absolutely precise and consistent. In terms of Patrick's response to you, where he said, no, we'll still need architects in the metaverse, do you take a different view now, or do you still stand by your comments that the metaverse is potentially the domain that is really most likely to be, let's say, transformed by these AI tools?
I still keep my same opinion, because the metaverse doesn't need to be precise. It's not real world. It's more like bring us this experience. So in that sense, metaverse is it not requires to be precise. It's not like a simulation in terms of the word model. It has to be precise. It has to follow the physical laws. So yeah, it's a totally different. And funny enough, that day we also, I mean, one day before that in FIU, Shang-He also bring up this issue of the VR, AR, XR, metaverse vs AI. It's kind of a similar logic that first of all, VR, AR, XR, and metaverse is a way of representation, showing how things can be presented. However, AI is not a representation tool, but it's a production tool. So it will produce the content, produce the data itself. So there's a plenty way to represent the content, and metaverse just one of it, and not the precise one. So I keep thinking that the architects is not really needed for metaverse. AI can do much better in terms of a 3D generation. I think it's coming soon on the long precise 3D models in the metaverse. Yeah, that is something I don't think architects should spend too much time on it. However, the interaction between the virtual world and the physical world is something we can think of. That is not something AI is stepping and to do this creative design in between. So this is something worth to look into. However, like Meta, they are also using this metaverse to do simulations. That will require a precise model. I think that is something slightly different compared to the metaverse we were talking about to give an experience, but that is more like a digital twin of the physical world. Like I don't know if you guys see the ones that they use the digital twin, like digital twin of the home to train the robotic all those machines to go around the room to clean up the room. Yeah, so those ones, it will still require a precise digital twin model in the virtual world. But that is, I don't think that is the, that is perhaps another way of the metaverse that's not the AI is chasing to. However, AI can duplicate certain digital twin, like what we do. I mean, some people may also know that what Xcool is have done before. It's a precise 3D model in the virtual world, you can see it. So in this way, yes, AI still can do really good generations for the precise models. However, the difficulty is we have to go further with the different requirements and link back to the real components or the regulations of different regions. So yeah, Neil, I still keep thinking the same idea that architects should not really focus on like a metaverse to do it in a traditional way, but use AI or use this kind of tools to get better of the design. The design is not just about representation, let's say. Metaverse is kind of a representation, right? So the design we should really focus is the performance, let's say, and the balance different situations or requirements of the reality. So that is something we should come across with the different issues, scenarios, or arguments, solutions that we could have for the design. Yeah, Neil.
Yeah, maybe in a second I want to bring Ela back in, but just going to ask you one quick question, because we had a discussion a while back, and I was floating the idea that, you know, you and other companies are pushing forward developing this software in a very interesting way. But my speculation was that maybe we were all going to be surprised by something that came up from the world of LLMs, that suddenly something would be produced. And I asked you this question about whether we're likely to get that in terms of could we produce an architecture and and you said, well, no, the problem is that 3D is very unforgiving. It's very, very difficult to work in that domain. Working with words is a different world entirely. After all, we only have a certain number of letters in the alphabet. It's very clear, but 3D is very challenging. However, the metaverse doesn't really need to be that precise in some way. But do you still hold by that, the fact that it would be impossible to really get there with LLMs, or very difficult to get there with LLMs, that LLMs won't be able to do quite what we need?
First of all, I think we need to have a good understanding of LLM. It's a large language model. So it's a language. It's a kind of a way we communicate. And I think it's just different models that LLM can proceed with. For instance, the large language model can use the apps behind it to support it. It will like kind of agent in between you and the machine. For instance, there's 100 of those apps, and you don't know which one to answer your question or to build your model. But large language model can be the one in between to help you to find out what is the best apps to do certain tasks. For instance, there could be a possibility that a large language model can translate your words into more precise requests for instance, Grasshopper into the kind of scripting. And the scripting in Grasshopper can use the basic the capability of Rhino, which is the geometry, and to generate the things you may think in your head. Yeah, so this is a new way of a workflow that large language model can proceed with. But it's not saying that large language model is generating 3D and so on. And then even for OpenAI and so far, if you want to generate an image there, it's using large language model to use the image generation model to generate image to you. So there's some other things behind it that and need to support a large language model to do it. Or you can just imagine it's the LLM is like a student or a trainee that will follow your orders to do stuff. But this training understand a lot of basic logic, but there's no specialty in any of the task. But it will get the experts to help this training to finish all the tasks. But the simple task, it will do it perfectly. Yeah.
Thanks, Wanyu. I'd like to bring Ela in. I don't know if you're still in Dubai, Wanyu, but Ela is based in Dubai. You guys must meet sometime.
Yeah, I'm in Abu Dhabi.
Oh, Abu Dhabi. Okay, that's just down the road.
Yes. Yeah, right next door.
Ela.
Hi, thanks, Neil.
Hi.
We should definitely meet, given that you're in Abu Dhabi. We drive back and forth quite often. So yeah, let's definitely organize.
Yeah,
to
sure.
exchange in person. But I would like to thank all the other contributors to the panel, because I couldn't stop taking notes based on what everybody else has said, and everything is thought-provoking. So really appreciative of everybody's input. I think my main contribution now, just because it's getting a bit late here and I need to put to bed our daughter, it's an observation on what is actually architecture today, given that we're talking about architecture in 3D and video to 3D potentially quite a lot. Mainly following what George and Daniel Escobar has brought up. And also some of the projects that we're currently working on right now. I would like to ask a broader question to you all, and also what Joshua has said, which I'm going to refer to in a second. What is the performance, or how do we judge the performance of architecture today? Question mark. And I tell you what I want to say is that I think we underestimate at the moment the huge impact that social media has had on how we're designing buildings and designing spaces today, and therefore how much of an impact a video generator can have. And for me, for example, we're running a project right now, is a competition for a big tender where the client, who's the contractor, is asking specific zones within the spaces allocated for social media sharing and social media content generation. Therefore, we are designing with that, keeping in that kind of component within the creative process. Now, if the impact that an architecture and its photographic performance can have on social media, it's part of how we design buildings today. How much of simulating video architecture with a platform like OpenAI Sora can have in creating buildings that become more digital-centric rather than human-centric. Mommy is speaking. Digital-centric and digital-friendly rather than human-centric and human-friendly. So yeah, that's an open question to the other panelists. I would like to hear what the other architects have to say about this, because I think already we are designing architecture based on their performance with photographic content. How beautiful is a building? How fantastic looks a building? And how beautiful videos we can create within the building. Therefore, simulating at a digital way, I'm not so sure it's going to improve the physical presence and the physical life of the buildings we are creating. I have a brief example to mention in relation to this. There is, Ross and I have been traveling in Korea a few times, and there is a beautiful Zaha building in the center of Seoul and the center square. I forgot the actual name, but for example, it's beautiful on photographs. At a physical level, the scale of the building is outrageous, meaning it's so phenomenally big and monumental that is, I don't know, 80% empty, and its volume is almost offensive. It almost feels offensive to a human kind of scale. Yeah. So how does that relate to now designing buildings with a digital performance, a digital simulation performance? Is urbanism going to get better? But better how? Better digitally or better physically? Anyway, I just wanted to say those. Thank you.
Thanks, Ela. Always so your comments are so incisive. It's thanks for your contribution. Maybe I could just ask Gustavo, who's here on our Zoom conversation, who's been listening attentively to all these things, making comments in the chat, for an overview of the kind of, or thoughts on the discussion so far. Gustavo, great to see you.
Wow, that's a huge responsibility, Neil. Thank you. I'm very humbled to be here. I think I've grown and have been educated through Digital Futures in these talks, but mostly what I wanted to contribute was when Mustafa Suleiman came to UCSB, he was really talking at such a high level that all these companies are looking toward the future. They've already thought through the future GPTs, and he had a conceptual framework of what type of possible industries would be disrupted and how much I would say resources it would require to get there. So I think my my overall questions are to what is architecture. I think Ela pretty much said it, but I think the contributions for me are would be if we think about if each one of us had the control or the power or the resources to make these types of tools, like what would our contributions as architects or having the thousands of years of discipline that we've embodied, how would that change these tools? And I think as a researcher here at the university, what I understand is the scientists that I work with, they use huge data sets. They've generated these data. They're looking at how other data relates to theirs. And it's the newer generation that are using machine learning and these tools to really evolve their toolkits. But what Mustafa said here really caught my attention because I thought, well, if I'm a smart tech person, I would partner up with every movie studio and try to absorb all their digital data. If there's scripts that are involved in timelines, you would combine how that would probably reference a video frame. So at some level, I really enjoyed Daniel's summary that it is an actively learning world model. But I would pose a similar question to us. In the world, architects were required to protect humanity and also help evolve humanity through a sense of community and this shelter. So what are the core fundamental questions we need to ask ourselves? And how would we, if we had a chance to speak with you know, all the higher ups at OpenAI or governmental agencies or right now in the tech industry, what would we want these models to look like? And I am not, I'm very skeptical that these models are here to do anything other than to learn from us. So I think there was a previous panelist that spoke about it's interesting when these models are open to the public. And I think we're basically testing and looking creatively how to evolve these models. And these makers of these tools are learning simultaneously and will absorb all that knowledge again. But I just wanted to say thank you very much for today's conversation. It was very stimulating. My students have much enjoyed these conversations, and I wanted to thank you all.
Thank you, Gustavo. Let's say keep it in the present, but you've still got maybe some time to go. I mean, my question to you would be kind of in the end, well, okay, but we're also learning from these models. I think it's they're learning from us. I think it's kind of a two-way process, and I think the domain of architecture is still kind of, you know, it's a two-way process.
Yeah, Neil, one thing I put in the chat was Ela's talk about beauty and how we're going back and forth. The evolution of beauty, how Darwin Forgotten's theory of mate choice shapes animal world by Richard R. O. Prum. That to me was the first time that I even knew birds made architecture, and that's how they attracted mates. And actually the whole, I would say, evolution of the birds learning how to dance and how to grow their feathers. I think at some level, we can probably see that as a metaphor for what we're doing with these tools. Those individuals in social media who make beautiful imagery seem to be getting the clients, seem to be getting the attention. So I think goes along with your thesis, Neil,
we're basically these tool users, but we're also creatively evolving these tools as well.
Yes, no, absolutely. I can't help thinking about the kind of how people delighted when their building has been used for a wedding shot, for example. But just to kind of make to add something into the conversation, just to kind of clarify things, because all these figures are being mentioned, and maybe not so many of the audience are aware of them. Mustafa Suleyman is one of the co-founders, was one of the co-founders of DeepMind in London. Now, within this soap opera that's going on right now, this was DeepMind was crucial, because not only was it developing in the form of AlphaGo and so on, the first hint of AGI, but it also was acquired by Google. And this set the alarm bells going in terms of what Elon Musk was interested in. This is what he claims anyway in the recent lawsuit. And he wanted to make OpenAI open, so it wasn't the property of one of these mega companies. Of course, that failed and so on. And in the end, the acquisition, as it were, of OpenAI by Microsoft kind of paralleled and echoed the acquisition of DeepMind by Google. But what is happening, Mustafa Suleyman, of course, now he's in Silicon Valley. He has a startup where he's developing a personal intelligence, PI, that he's talking about, which is some kind of assistant that will know you very well and that will be able to provide you with advice. I think that's fascinating. What that means in terms of, let's say, our alter ego, how we operate as people, is super interesting. And it kind of relates back to some of the discussions that Andy Clark, whom we had on last week, the week for last, was talking about, in a sense of how these devices become a prosthesis to our imagination. We're all cyborgs, and we all have these devices. They're part of how we think. We think with them. And to what extent, once we have our own personal AI, will we shift into a different mode of operation? I think already some people use ChatGPT in that way as a kind of advisor, as it were. Now it can become personalized. So I would be fascinated to see what Pi will lead to in the end. So I want to just open it up now to some general discussions. I don't know whether I could put Daniel on the spot, but I mean, I think your contribution, Daniel Bolojan, at the very beginning opened up a whole series of different sort of things. And I'm wondering whether you want to reflect on what has been said since then in response to some of your comments, or if that's too much, don't worry. But yeah,
no, I can contribute here. But of course, like my contribution are going to be limited. I think there are a lot of great people here, like having different perspectives. So, I mean, if I'm thinking about architecture and how, in a way, these kind of models could help, even like world simulator, like even like I said at the beginning, you know, right now we call it a war simulator, yet it's still very limited. But for some of you, probably you're aware that I was, for 4 years, I was a researcher in Vienna with Patrick on a project called agent-based parametric semiology. And pretty much what we were looking at there, we were looking at this kind of idea of how human behavior influences space and how space influences human behavior. So that, to put it very, you know, briefly, yeah. And out of that research, in a way, like a lot of questions, personally, I started to develop a lot of questions like, you know, what's happening very often in architecture is that we rely a lot on our assumptions, in a way, on how a building is going to be used by the users, about how a building maybe is going to be situated in a city, and how the people are going to interact in kind of places that we are designing. And what's happening is that very often, like, we have this kind of very, very delayed, in a way, feedback loops, yeah? So for example, let's say that I'm designing a building. So I'm designing an opera house. And of course, I'm going to make a bunch of assumptions of, you know, how that building is going to behave, or how not behave, but how people are going to interact in that building. And probably it's going to take me, like, let's be conservative. So it's going to take me 5 years, perhaps, to build that, from the initial starting phase to up to the construction and having it open. It's probably 5 years, yeah, 5-6 years. I've been to project that took like 12 years to build. So by the time you have the project, suddenly now you start to observe, how people are using the space, and you might realize that people are not using the space the right way. And okay, so now you have feedback. So after 5-6 years, you have feedback. So when are you going to have the chance now to get another project that is quite similar for you to be able to apply the kind of feedback that you got from the first project? So probably it's going to take you another like 1-2 years until you get another project, maybe the same scale, the same, type. And now it's going to take you another 5-6 years for you to implement the feedback. And then you're going to, get the feedback after the building is open, you're going to get the feedback. So it's really going to take, it takes a lot of time in a way for us to really get it right in a way. So my hope with this kind of like language models and this kind of massive, world models, it's almost like this kind of idea of learning from synthetic data in a way. So if we are able to create this kind of simulations of worlds and have a way of simulating how people might interact in that space, is that going to increase in a way our intuition or improve our intuition in terms of how people are going to actually use that space in real life? And is that going to shorten in a way this kind of feedback loop that we have usually, that it's a super long delay in a way? And I think also this kind of not language, but this kind of large models like world models, like let's say Sora, they could train in a way on all these kind of simulations that we are running, on this kind of synthetic data, you might call it, And you might say, well, that could be problematic because, if the synthetic data is wrong, then the models keep going to generate things wrong. It might be if we are looking at it in a very simplistic way, like the way that the training happens, then yes, it might create a problem. But we all know that it's not just data set, and this is a sort of misconception in architecture. The discussion revolves around like just the balance of data set. It's as if like as architects, we only know about AI in terms of data distribution, but we all know that that's not true. It's about alignment, how you are aligning in a way the models. It's not so much like the data set, But the idea is that, okay, you have this kind of then synthetic data, that is being generated. The more you generate new worlds and new versions of the world. And imagine also with diffusion models, you have this you have a prompt and you have a seed. So you have a prompt and you have multiple variations of the same prompt in a way. So the same way we might have in a way with Sora, you have a prompt, a description of a scene, but then you have like multiple iterations of that scene in a way, So that's a sort of synthetic data that's being generated. And I think this is very similar with the way that we humans learn constantly. So we are, as humans, we are constantly training our brain in a way with self-generated data, And what I mean by that is we have this kind of self-reflection in a way, We are thinking and solving a problem, imagining scenarios and so on, and that's how in a way we solve certain problems. We have all these kind of self-reflections and so on. So that's a sort of like type of, let's say, synthetic data that we are generating in our brains, and that's how probably also this kind of digital worlds could learn and could perhaps improve and aid us in a way when it comes to making better designs and so on. Now, this opinion that I have for sure is not addressing all the intricacies in a way when it comes to architecture, but I think it's touching on one subject that personally I'm more familiar with when it comes to this kind of intuition and interaction in a way with how people interact with the space. So that's my take on that. That probably it's answering Ila's question about what is architecture today. Other comments that I will make is also like we always have this kind of questions of how we are going to deal with this kind of deepfakes and distinguish between real and fake and so on. And I will say that this problem is not native to AI. So this problem, and as a society, somehow we still didn't catch up in a way with with this problem. Yeah, so we have this problem already since social media. So if you think about social media, how many negative aspects social media has, yet we have no tools in a way to counteract in a way those kind of negative aspects of social media. Yeah? You look also at Instagram, for example. There are studies in a way that are putting something close to 30%, perhaps something like that. Like depression levels are going up 30% just because of people using, you know, social media and so on, Instagram. And do we have ways of contracting that? And for me, the question will be then, or I will switch or flip in a way the problem and say, you know, are we focusing actually on developing tools that help us with this? Yeah. Personally, I'm a very pro technology person, like as many of you probably know me. So rather than saying I'm going to stop this X technology because of the negative aspect that it might create or negative effects that it might create, I'm rather flipping it and saying, okay, am I developing the tools to aid, in a way, people with dealing with these tools? Yeah. So if we have issues of deepfakes, how do we enhance, in a way, humans to be able to distinguish then between real and not real? Yeah. So that's how I would look at it, rather than just defaulting to, you know, the issues that we have. But again, it's an issue that it's before AI. Yeah? We had this issue since social media, and even right now we don't have a clear way of dealing with social media. Yeah, so I think the time is kind of running out on us. So the faster we move, the better. Yeah. Another thing that I'll just want to add is, and I'm just going to read probably a quote. I think that is going to help a bit the discussion. It has to do with this kind of idea of how do we relate to these kind of AI models. Very often we are looking at them as tools that replace our brain in a way. But I found, in a way, one interesting quote from John Nostra. I'm not very familiar with him, but from his bio, saying that he's a thinker entrenched in the world of technology, science, and medicine. And he has this interesting quote: AI isn't our second brain, it's our third hemisphere. And then he goes by saying, modern neuroscience disputes the simplistic idea of the brain being divided into left and right hemispheres, each responsible for specific functions. Research now shows that both brain hemispheres work together, engaging in extensive interhemispheric communication to support various cognitive tasks. This collaboration or this collaborative process highlights the brain's ability to integrate and adapt, offering insights into how human cognition might harmoniously interact with large language models. So I just find it an interesting, in a way, take, rather than thinking, you know, like AI as something that replaces, maybe something that extends, you know. So I'll leave it to that for now.
Thanks, Daniel. Thoughtful as ever. I guess what I find interesting about today's discussion is that we started off looking at a simple text to video sort of model, and yet all these other issues, sociological, philosophical, psychological, neuroscientific, and so on, have kind of raised their head. It's almost become a vehicle to address a whole panoply of other concerns, and I think that's only right. A tool is never just a tool. It's also is in some senses opening up a new world and all the challenges that we have with it. And I think this discussion has been great.
Can I add here, like, and I think somebody was saying, I think it was George, saying that, you know, we are just at the beginning of this, and this is day one probably, yeah, of all this. And I think as architects, probably we are still defaulting to the traditional way of thinking about architecture. And I'm just curious, in a way, like how that new native way of thinking about architecture is now in the context of AI, you know. And I'm saying this because, you know, if you look throughout history, like different tools. So we have this kind of code, like we shape our tools, thereafter our tools shape us in a way. But if you look also history of architecture, like the impact different tools had on architecture and on the way that we conceptualize architecture in a way, thought about architecture. Yeah. So if you look at, you just had a pencil, what kind of architecture we designed with that, and which were our ideas and concepts about architecture back then. And then suddenly you have computation, and you start to think about architecture as this kind of like multi-systems where you have subsystems that have this kind of interconnected relationship between them, and it's about like how each system reacts to the other system and so on. Yeah, but that, I think, that idea emerged in a way out of a lot of ideas, complexity theory and so on, a different kind of progress done in science, and suddenly had an impact in a way on the way that we start to understand architecture, yeah, and also like conceptualize it and also design it and so on. Yeah, and for me right now, this is a question that I'm like hustling with, let's say, or trying to figure out, and this is what I'm pushing my students to think as well, is which are those native methods and ideas that are native to AI, not to computation. I'm not interested in using AI as a way of mimicking the conventional way of doing design through computational means, let's say. Yeah. Is there a different way of thinking that it's prompted by AI that expands perhaps of what we understand through architecture? So I think that's where the interesting thing will be, and that's why I'm open to challenge in a way this kind of idea of, do we really need in a way all these types of data sets? And most of you know that I'm always pushing for more multimodality. There is a paper that I wrote with some colleagues here, is Language All We Need, where we are making in a way the argument that you cannot rely only on language. But in some aspects, in a way, I think we have a lot of preconceptions about how architecture has to be designed and built. And it's just interesting, like how, you have all these kind of models that you never thought that, just by using pixels, you can achieve this kind of results. Yeah. And it was computer science in a way, that because they are not constrained by preconceived ideas about architecture, they had the freedom in a way to just, explore the idea of pixel-based, a kind of information, let's say. And out of that, suddenly something emerges that you can actually simulate 3D worlds just through pixels. You don't need 3D. If you were to ask an architect before that, an architect will say, well, you cannot do that. You need a 3D model to simulate a 3D world. And for me, that's an interesting thing. Like, it seems like we have a lot of blind spots as architects. And it's interesting in a way how this kind of AI models kind of, they put us on a spotlight to show how blinded we are to certain things. Yeah. We cannot hear you.
Okay, sorry. Yeah, that was incredible. Thank you, Dennis. Super interesting. I mean, of course, tools change everything, and I think that Rem Kool has comments on how the elevator, if you can see that as a tool, totally changed architecture. You can then have multi-story buildings and so on and so on. And I also think how our minds are colonized by certain terms that are introduced by technologies. And I mean, Benjamin is, as soon as the camera came along, photography, his whole lexicon changed by using terms such as the snapshot and so on, entering into it. And I think even we have a word like Google, that changes on us also how we perceive the world. So I absolutely think that these things will change how we understand the world. No question about that. And which makes it kind of exciting and dynamic in some ways. And I think we have to go with the flow. George, let me ask you to kind of comment and feedback on some of those comments.
Yeah, thanks. I think what this brings forward is also an interesting new opportunity. We're kind of commenting on architecture and its traditional, the way we have seen it in the recent history. However, I think this interesting idea of tools versus what that produces is really interesting. It brings to a neo approach of going back to Brunelleschi or then Leon Battista Alberti. It's that initial moment in time when we've made a distinction between builder and thinker. between architects from those craftsmen and laborers involved in the construction process. So I think with that came more responsibilities, whereas it could be aesthetic or the dealing with complexities of site, however, of construction sites. However, that brings forward, using all these AI tools bring forward a new opportunity, a new value propositions that we need to start talking about. So we're talking about neuroscience, with computer science. There's so many. What these tools have done is broadened out the discipline in ways we wouldn't have previously imagined. So I like to bring forward these questions you brought up, Daniel, as well, but also start going in a cross-disciplinary approach. So let's say within more traditional answer could be considering, you think of tools, for example, Delve. Delve started its marketing as being for architects and real estate. However, now you go on their websites for real estate. And there's this interesting duality between the democratization of these tools and possibly a displacement of architects. So why shouldn't we leverage those tools and start considering ourselves as, we've discussed this in the past, architect as developer, architect as owner operator, architect as prefabricator, leveraging AI, architect as contract administrator, architect as data set maker. I like to throw in this idea of a new value proposition as being the creator of data set as a service. I think there's huge value, especially when viewing this from like a safety or standard of care perspective, or how can we work in a way similar to up codes and start embedding compliance or aesthetics within a building? Could we start finding new ways of considering what practice means today? And that brings this really amazing discussion. I love how you bring it up, this idea of feedback loop, Daniel. I think feedback is really such a key element in everything we're discussing today. And in responding to Ayla's question, I'm a British architect, so the first moment in which the public is made aware of a project is in a public consultation. Usually that happens so late in the game, too late usually for anything to change. And so for Daniel, for you to bring up that discussion post-construction is, with today's tools is wild to consider. You have to wait 14, 10, 5, the years problematic is definitely an opportunity. So how could we start? I think there's real benefits in imagining future interfaces where we can embed these simulations, this feedback loop idea within a more possibly participatory design approach or learning from post-construction documentation. When I say data as a service, it doesn't have to be just image data set or 3D data set, you name it. But it could also be like that post-occupancy evaluation. How did a building perform? What are the qualitative aspects which made that building beautiful or that atrium successful? I think what this is doing is really opening up a broader discussion of what values or value propositions that could emerge as a profession. But thanks for bringing that up.
I think that sums up today's session as a whole. It's opening up this Pandora's box of different kind of issues. We thought we were talking about tools, but as soon as you start talking about the affordances of a tool is never such a simple tool. It changes everything. And I think I agree that Daniel's comments on the feedback are absolutely crucial in terms of trying to engage with this. We should be trying to wrap up. I don't know if anyone has got any pressing final comments to make to this session. It's been and actually you never quite know how these sessions are going to go, but here is an issue, here is a tool. What does it provoke in terms of thoughts from a group of architects? And I think it's been incredibly useful. Maybe Wanyu, you might like to add some comments.
There's no really comments, but I think yeah, there's plenty things that we can look into as architects. Not just that this technology is going on by itself, but first of all, think about our nature of our principle, our discipline, and see what we can do with those technologies. because the trend is going with all the AI companies. It's a majorly in general way, let's say, but in professional fields, it still need our creation to find out what is the best options for this profession. Yeah. Thanks, Neil.
Thanks, Wanyu. Angelica, do you want to kind of chip in something?
Yeah, I was just thinking I'm asking Wanyu, but it's just what I'm more concerned now, how can we integrate all these tools in our design process? What kind of design process are you having? Like for instance, you use the this image generating AI just for the initial part of the design process, and then just to get ideas. And then how do you, and then I see also that it's being used to make renderings of the models that you are working with. So when you made a plugin with SketchUp, maybe we have a plugin for any BIM program. So I see it both in both ends, like the beginning and at the end. But how can we, that's the big question, how can we use this all along? Or is it supposed to be like a different step process like we have today? Like we first can start the process by drawing, sketching, or using physics models. And then how do you integrate this into being something different and then the renderings? But do you see like a vision of like a continuous flow, or we keep like changing platforms and ways of drawing? Is part of our inner way of designing. And also for Daniel to comment that, because I remember that he speaks about working with different models and different programs. How do you see our new way of design? Thanks.
Yeah, thanks for your question. Yeah, sorry. Thanks for your question. I just answered in short. Currently, like LookX and all those image and all those generation I have are based on images, videos, pixels, or visual data. But I totally understand that architect will dealing with the precise stuff. So we already have something as Xcool to generate the master plan scale, building scale, and later to the interior scale with MEP structure and so on. But it won't be for every typologies. We will focus on certain typology to generate it. So answer your question in short, yes. We are thinking of a way that in one go, you can design from A to Z. And this Z is not something from our imagination, but we're using the data source from the manufacturers, meaning we will more prefer a DFMA logic design for manufacturing and assembling that will associate with how the things can be made out. And also for performative design that will involving in all those simulation simultaneously with the generation. So the design will be not just like imagination or some nice form, but should be also involving in how it can be used in terms of the ventilation, the noise level, the sun radiation, the people's the walking flow, and so on. So this is something we are working with, and later we will share all those capability, our platform, and all the designer and architects. Yeah, thanks.
Thanks. Can't wait to see.
Thank you.
Daniel, do you want to comment on the second question? That
Yeah, do we still have time? Just briefly, then I'll be brief. Yeah, so for me, it's like depends now. Like if I'm engaging in a very conceptual project, then the workflows, methods that I'm going to use are quite different than if I'm saying I'm engaging in a project in practice, for example. Yeah, so in DeepHuman Blau, for example, we have a lot of the nodes in the network. They are more pragmatic in certain aspects. They are not so explorative, but in early phases of design, you can engage in very explorative kind of, or you can engage with very explorative methods, yeah. And here it's like sometimes, you have various, I think it's important to understand various models that you work with and to understand their utility, let's say, at different levels of design. So for example, am I going to use Midjourney super early on? Depends, yeah. Because if I use Midjourney very too early on, and Midjourney is going to give me like super realistic renders with high resolution details, it might be that that's actually stiffening a bit the creative process, yeah. And I don't want that, yeah. I want to perhaps at the beginning to engage in a more open-ended kind of exploration, and then slowly zoomed in a way into a certain direction, yeah. If I just from the very beginning, you know, I start with high resolution, then it's going to be very hard. The direction is already defined then by the bias in a way, or the preferences of the network, yeah. So because of that, then, you know, you might say, well, early on, perhaps I engage with models that are not so precise, you know, and I'm using, in a way, models that are not so perfect, particularly because they are not perfect, yeah, because that gives me like certain interpretations, certain results that leave space for interpretation, yeah, and I can look at those and then, you know, realize how to or try to figure out how to connect dots between different kind of levels. And then from there, perhaps I get to a point where I start to engage in a more precise kind of, with a more precise model, yeah. So I see it in a way that way. Now, this is, I'll say, prior to Sora. Now, after Sora, it might be that certain things are going to be, that we are going to think about them differently, you know. But yeah, for now, I think in practice still, you have to engage in this kind of way, just because, you know, there's certain output that is requested from you, a sort of format, yeah. Like for example, the 3Ds, the floor plan sections, you know, that's practice right now today. But if you switch to a more conceptual project, I will personally dismiss in a way all those, and I'll say, I think even just the tools that we have today, they already grant you permission in a way to say the future is going to be different than just floor plan sections and, you know, design processes that we are familiar with right now. Yeah, I think it's going to be something completely different.
Thanks.
I think that we need to wrap up, because this could go on forever, and it should go on forever. I think we should need to pick up on this in some time. Certainly when Sora is actually launched and is available to everyone to use, that'll be a different world. Things are changing on a daily basis. This has been a fantastic discussion. I think that it's really exceeded what I expected. I wasn't quite sure what to expect, actually, but just to open up a forum for debate about this particular tool. But it's gone way beyond this tool, and I think we could see the repercussions going deep into the sort of the whole kind of way of conceptualizing architecture, and it will change architecture. I think this has become fairly clear to me that all these tools have their affordances, and we operate with those affordances, and the discourse changes and emerges and mutates. And nothing is static. And the comment that was made before attributed to Norman Foster, I think it comes from way back when. The only constant is change, and I think that is definitely the case. And the only way we can kind of keep up with these changes is by having these debates and bringing in experts like yourselves to really bounce around ideas and then to share these things around the globe. So this has, I think, been an incredible contribution to the debate that will be uploaded onto our website, onto our YouTube channel, for everyone to appreciate. This is something that is affecting the whole world right now. And so I want to thank you for all this. I want to thank particularly our guests today, gathered here today, debating all this. I want to thank the team that is behind the Digital Futures team that's behind all this, setting up this session. Look, I would like to thank also OpenAI for launching something that is astonishing in its own way. And I think, you know, for better or for worse, it is going to be changing, and we are in a very exciting and almost, well, I would say terrifying also moment of complete change. And I think the main point is to be alert to these possibilities and able to act and respond and to change and mutate according to those tools themselves. I think the idea of feedback that Daniel was talking about, Daniel Bolojan, is important, certainly vital to incorporate into our discourse. Let me finish finally by saying tomorrow we have another session, and we're on our architecture and philosophy series, but we're operating in a different time slot. We have tomorrow, well, the same time slot in terms of the United States, but the clocks change tomorrow, which will throw things out in terms of the timing elsewhere. So please be alert to that. That everything is going to be. That means it's going to be 1 hour earlier in Europe, 1 hour earlier in China. So our session on Spinoza tomorrow starts at 10 a.m. EST, Eastern Central Time. That means I'm getting this right, sorry, 3 p.m., 1500 hours in Central Europe, and it means 10 o'clock in China. The good thing about that is that now it's early enough for most Chinese followers to follow. So thank you so much, everyone. This has been an incredible contribution.
Yeah, and in 30 minutes, we have another Portuguese session on being an AI. If you want people to stay, it's going to be in Portuguese. Just 30 minutes
Fabulous.
from now.
So I think this is also part of it, sharing it in different languages. Thank you, Angelica, for organizing that session. So to be continued. Thank you, everybody. An amazing, provocative, thought-provoking session, and a very important session. Thank you so much.
Thank you, everyone.
Thank you. Bye.
Thank you, everyone.